I'm going to do examples 2 and 3 on the same video here. They're the same problem. The only difference is on example 2 I want to eliminate y. On example 3 I'm going to eliminate x. So it's the same problem. One of the things that people when they first learn the elimination technique is that they get concerned with is what should I get rid of? And people think that it's important what I get rid of. So in this case I'm going to eliminate y. So eliminating y just means that I'm going to make these two guys be the same number but opposite. Okay, notice they're already opposite sign, but 3 and 4 aren't the same number, right? And again, through multiplication I need to make them the same number, so what can I make them become? 12. Very good. So, you have to make that decision. Just look at these. I need to multiply both of these, one of these, or both of these by some number to make them the same number. 3 times 4, 4 times 3, I can make them both into 12. Once you see what number it is, the magic number, that's what you multiply by. So multiply the top equation by 4, or multiply the bottom equation times 3. Because the signs are already opposite of one another, I don't have to multiply by any negatives. The opposite signs are already showing up. So, the top equation in blue, 4 times 2x is 8x, 4 times negative 3y is negative 12y, 4 times 5 equals 20. On the bottom, 3 times 3x is 9x, 3 times positive 4y is positive 12y, 3 times negative 18 is negative 54. A couple of things I want to bring to your attention right now when people mess up on this technique. The most common mistake, they'll do 4 times 2 and 4 times 3, forget the 4 times 5. That happens quite often. So make sure each and every object gets multiplied. The other thing, that minus sign right there, sometimes people don't see minus signs. So be careful, take it slow enough that you can see all the pieces to things. Make sure the signs come out to what they should be. And again, multiplied by 4, multiplied by 3, and the end result, my y terms, what I want to eliminate y, the y terms are opposites one another. So, if I add the equations together now, 8x plus 9x is 17x, negative and positive 12y, opposites cancel, 20 minus 54 is negative 34. Now, the rule says to add the equations, we're adding algebraically. So if the signs are the same as in the case of the x objects, we're going to add the numbers. If the signs are different, we subtract the numbers. The bigger number always determines the sign of the answer. Then the division step, divide by 17. That gets me x equals negative 2. Okay. Now what I want you to understand here is this. When you use the elimination method, you eliminate a variable, right? Whatever you eliminate finds the other one. So if I need to find x only, I'm going to eliminate y only. If I have to find y only, I'm going to eliminate x only. Usually I have to find both. Alright? But if I eliminate y, I find x. Once I know what x is, I go back to an equation. I can go right here, or here, or here, or here. Any one of those equations will do. I'm going to change x to its value. I'm going to go to the top equation. 2x minus 3y is equal to 5 is the equation. Notice I didn't write an x down because x equals negative 2. So again, that's the top equation, exactly the same. I just replaced the x with a negative 2. Negative 4 minus 3y is equal to 5. We slide the 4, it becomes positive. Negative 3y is equal to positive 9. Divide by negative 3y is equal to negative 3. And just like that, negative 2, negative 3 is the correct answer to the problem. Alright? Most of the problems at this point should come out to nice integer answers like that. If you get a fraction, don't immediately think it's wrong. Maybe just check over your work. There are a couple in there, I think, that have fraction answers, but most of them come out to integers. And again, that's example 2. That's the problem. Notice example 3, the exact same problem. Only difference in the process here is this says eliminate x. Eliminate x. So I want to get rid of x. So I want these two guys to be opposite the same number. So first of all, let's focus on the same number part. What number can I make them become, Parker? The x's, what number can I make them become?
6.
6, very good.
Ours doesn't say eliminate x.
Well, I put that up there just for fun. They're the same problem, so I put that up there.
Okay.
All right. So, I can make both of these become 6, but right now if I make this 6 and this 6, they're both positive 6, right?
Mm-hmm.
All right. So I want the one to be negative 6. Which one do you want to be negative 6? The top or the bottom?
Bottom.
Bottom. Doesn't matter. But Mitchell made a decision. That's good. Making a decision is going to be your key. So, we'll multiply the top equation times positive 3 and the bottom equation times negative 2. Okay? The top equation will get a positive 6x. The bottom equation now will get a negative 6x. So again, that's my goal in this step. And the only step you really have to think a whole lot about is this one step. I want these to be same but opposite. What do I need to multiply to make that happen? So the top equation times 3, everything gets tripled. 3 times 2x is 6x. 3 times negative 3y is negative 9y. 3 times 5 is positive 15. Bottom equation, everything's doubled and multiplied by negative, so the sign changes. Negative 2 times 3x is negative 6x. Negative 2 times positive 4y is negative 8y. Negative 2 times negative 18 is positive 36. If you do that step correctly, whatever it is you decided to eliminate, again, whatever this is, you should be looking at that exact picture there. The two coefficients are opposites of the same number. 6x minus 6x goes away. Negative 9 minus 8 makes negative 17y. 15 plus 36 is equal to positive 51. Same sign added, same sign added. And divide both sides by negative 17. Y is equal to negative 3.
It's a different sign.
Well, that's a negative, that's a positive, right? So you divide by the negative 17. Opposite signs create a negative answer when you divide. So keep in mind the rules of signs with adding and subtracting. The bigger number determines the sign. With multiplication division, same sign positive, different signs negative.
No, but why 36?
Why is that positive 36?
Oh yeah, never mind.
When I multiply by the negative 2, the two negatives made a positive 36.
Oh, the camera's in the way.
Oh, I'm sorry, yeah. Yeah, these are the same sign here, yep. So I add those together. So y is equal to negative 3. And then again, once I know what y is, I can go ahead and find x. I'm going to go back here again to find x. 2x minus 3y is equal to 5. Instead of writing down y, I'm going to write down negative 3 because that's what y equals. So 2x plus 9 is equal to 5. We move the 9 over. 2x equals negative 4. Divide by 2, we get x equals negative 2. So looking at them side by side, same exact answer both times to the same problem. Shouldn't get different answers to the same problem. But again, the first one I got rid of y, I found x first. The second one I got rid of x, I found y first. Make a decision, stick to your decision, don't change your mind halfway through. One other thing I want to bring to your attention, some of you as far as showing your work and going in an organized fashion through your work, let me show you a couple things that happen to people. A lot of times I'll see what happen to people.
Why is y equal to negative 3 every single time?
Because it was the same problem, Parker. The first problem was different, but it's just a coincidence that it was the same in the first one, but the second and third problems are exactly the same problem.
Yeah.
So it should be the same thing there, right?
Yeah.
Why is negative 3 in the first problem? Because we're trying to mess with your brain. I don't
Yeah.
know. That's why.
That's why.
All right, here's something I see a lot of people doing these problems. They just throw the variables out of the problem, like right around here. They'll just write negative 17 and 51, and then they'll write negative 3. That's the right answer, but what is it, x or y? You're not writing it down, okay? There's an x answer and there's a y answer, and the letter that each thing is matters. So make sure that the letter sticks to the thing all the way through. Don't abandon the variables in your work. That's, again, something commonly done by people. I guess if you're more aware of what's going on in algebra, you guys, this is your first year in algebra. I've been doing it for years. I see the importance of little small details like that, where sometimes high school students don't see the importance of details like that. But again, do not abandon your variables in your work. Make sure they stick all the way through so you know what your answer represents. And again, the other thing that happens most often is with the distributive property, multiply, multiply, forget. I see so many times this number doesn't get multiplied by that number. So be careful that each object, there's 3 numbers usually, an x, a y, and a number. All 3 things get multiplied through. Do not forget to multiply that constant.